Hi everyone, KDman74 here. Well, I've got a couple of videos on my channel already. So if you think any of them helped you or you want some more help, comments are always welcome. Please let me know. Okay. So today we're talking about A level, H2 maths, integration of Trigo expressions and some other Trigo solving of Trigo equations and parametric expressions. Well, this isn't the easiest question to do, so stay with me. Yep. So this is question 10 of last year's A level paper. This is paper 1, I believe. So question 10 towards the end. So previously I did question 12 on vectors. So now I'm doing question 10. This looks quite intimidating actually, because you have two parametric parametric equations. In my experience, have always been hard for students. It's hard for me too, actually. But anyway, let's just keep calm. So if you're at this stage of your A-level revision, you should be quite comfortable already. Just that this question is a bit difficult. That's why I chose to highlight this. Okay, so you have x and y defined in terms of the parameter theta. So, okay, so far so good. And then they want you to sketch C and state the Cartesian equation of its line of symmetry. So, I mean, maybe some of you out there who are listening to this video, you're maths geniuses. So you can just picture in your head what this cardioid looks like. Well, I can't, so I had to depend on my GC for this. Then you're going to say, hey, Cher, how to use GC for this? GC cannot handle unknowns, there's unknown A here. So I say not to worry. Why don't you imagine A as just any positive number? And we're going to see what we get. So maybe you imagine A as 1. That would be the simplest case. So, and then you key it into your GC, okay? Using the parametric mode. So by now, right, you should be very competent in using your GC now, okay, as you're studying for your revision, okay? So let me just put this in my GC and come up with the sketch as soon as I can. Okay, this one. Okay, X and Y, sketch C, right, they mean that put it in terms of the X and Y axis. So I apologize, one node doesn't have a ruler, so it's really hard for me to draw nicely. So as I was saying, this is a very typical cardioid. So this one, okay, so it looks something like this, but actually this is not good enough, okay? Why? Because if you look closely at your GC, right, the x-intercept on this side is A, whatever value of A you put in, and the x-intercept on this side is 3A. Okay? Sketches do not have to be plotted like perfect accuracy, but proportionally they must be correct. Okay? So this is actually negative 3A. And because this is a cardioid, please make it as symmetrical as possible. So, roughly like this. Okay, I tried my best. So this should be good enough. I mean, please, I'm drawing on my tablet here, so it's kind of hard, but please make this more curved. Okay, please make this small part more symmetrical and curved. Okay, so that's actually just one mark, This is a GC question, so they're not going to give you a lot of marks for this. So this is here. And then you're going to state the line of symmetry, right? So the line of symmetry here is, of course, the x-axis. Y equals to 0. Okay? So that gave us 2 marks already. Not too difficult. Then part 2 requires us to do some solving. Okay? So whenever you have something that meets the x-axis, when C meets the x-axis, so the y coordinate is 0. So scrolling back up, right, y is equals to a multiplied by the 2 sine theta minus sine 2 theta, okay? So blah blah blah, y equals to 0, so it's a 2 sine theta minus sine 2 theta equals to 0. So solving this shouldn't be too difficult, right? I know some of you hate Trigo, but too bad. In A-level H2 maths, right? Trigo is implied knowledge. So you have to be good at it at this stage. So what do we have here? So I'm going to have 2 sine theta minus 2 sine theta cos theta equals to 0. Factorize this. 2 sine theta, 1 minus cos theta equals to 0. So sine theta equals to 0 or cos theta equals to 1. Blah, blah, blah. So, you should be good at this by now. Just look at this. Equals to 0, 3 values. Equals to 1, 2 values. So therefore, I'm going to conclude straight away, not to take up too much time in this video. Theta would just be 0, pi, or 2 pi. Okay? That's it. So again, it's only worth 2 marks. You've got to be a bit quick. Now, part 3 is the one that's slightly harder. So now you want the area enclosed by the x-axis and the part of C above the y-axis. So given our sketch, which is not really good enough, but I just want to make this quick. So by the area enclosed by the x-axis over here, and the part of C above the x-axis, so we are talking about this part, right? This area. Show that is given by that expression there. So, it looks tough, kind of tough actually, which is why they're giving you 3 marks. Tough is relative. So how are we going to get the area enclosed? So not to worry. This is a parametric integration. So we need to know integral, right, is always, if you want to integrate something above the x-axis, you need to find the x coordinates, the lower limit, negative 3a, and the upper limit a. Find out what is it in x. Okay. Sorry, find out what is it in theta. Because we know the x value here is a and negative 3a, we need to know what theta is this. So you see this is the lower limit at negative 3a equals, upper limit here is positive a. This is the usual integration, right? Lower limit, integrate from lower limit to upper limit of some expression. So you should see this, right, as actually integrate something, integrate from negative 3a, negative 3a to a y dx would give us this actually. So we need to convert this into something to do with the parameter and integrate with respect to theta later on. So how are we going to do this? It looks kind of tough, which it is, but not to worry. So here we're going to make use of, I think we have some space here, so let me just make use of the space here in a different color, shall we? Okay. So we know that we're supposed to find the value of theta when x equals to a and x equals to negative 3a, isn't it? So let's see, when x, so it must have something to do with this theta, pi, and 2 pi that the question asks you to find, right? Because the way questions work, right? Part 1 is related to part 2 is related to part 3. Sorry, it's the other way around. 4 needs something from 3 needs something from 2 needs something from 1. Typically, that's what happens. So let's just check, okay? So when theta equals to 0, what was the actual value of x, shall we? So let's look at the x equation. X equals to the cosine something, right? X equals to a 2 cos theta minus cos 2 theta. We need to check this, shall we? So when x equals to 0, when theta equals to 0, so we are going to sub it in, right? So x will be equals to a multiplied by 2 cos 0 is actually 1, subtract cos 0, 1 equals to a. So at this point, right, this point here, right, is when theta equals to 0. So far, so good. So we just need to check these three special points, pi and 2 pi. I mean, if you're a genius, you would know that, okay, when theta is pi, right, actually it's negative 3a. But if you're not, let's just work out few more steps. 2 cos pi is negative 1, so it's negative 2. Cos 2 theta, 2 pi, right, is 1. So that's minus 1 here. Okay, I'm just doing it as quickly as I can so we can spend more time on the more fun things. Theta equals to pi over here. So just the final special point, right? I mean, you could have skipped this, but we're just doing this for completeness. Again, you sub this in correctly. 2 cos 2 pi minus cos 4 pi would give us 2 subtract 1 equals to a. Fine. So now we know that this, when we want to do this integration, right, we are integrating from, so required area, right? So area enclosed, or you can say required area or area enclosed, up to you. Required area is my preferred term. So integral y dx, okay? Lower limit negative 3a, upper limit a, then y dx. So it looks like, hey, we can do this, right? But y is in terms of theta, let's not forget. Y is in terms of theta. Let's just write down the equation in case we forget. A, 2 sine theta, subtract sine 2 theta. Okay, so that's what our y is. So if we put this expression for y inside, right, we'll get something in terms of theta. Of course, you can say, Joe, why you want to do this way? Can't we just find the Cartesian equation, y equals to something x? Actually, yes, you can, but it's kind of tough, and this question doesn't require you to do it that way. They structured this question to force you to do the parametric equation, which you must know. So, oh well, no choice. So let's just do this step by step. I really don't know why it's only worth 3 marks, but anyway. So let's just look at this here. This x. So what's dx? So dx, right? I need to differentiate both sides with respect to theta here to get something d theta. So when I differentiate dx with respect to d theta, right, I'll get dx d theta. And then the right hand side I also differentiate with respect to theta. This one we shouldn't spend too much time on it, right? You should be good at this now, by now. So which implies that dx is a times negative 2 sine theta plus 2 sine 2 theta d theta. So some of you will just say I multiply theta over, but please don't think that way. We are just saying, multiply theta on both sides, treat it as a fraction for convenience sake. But in reality, right, this d theta is an operator. We can't actually multiply it like a fraction. So of course, if you want to go into a lot of detail, we can, but that's not the time for this, okay? So just imagine that it's a fraction, you multiply over, so then now we have the expression for dx. Then for the required area, right, we've already established that when x equals to negative 3a, the lower limit is actually pi. Is it? Yes, it's pi. And also because we want to keep things simple, right? When the x equals to a, theta is just 0. Let's just keep things simple. Okay, then now this y, right, is a multiplied by 2 sine theta minus sine 2 theta multiplied by dx, right? Dx is a negative 2 sine theta plus 2 sine 2 theta close bracket d theta. So it's quite involved, this algebra here, but I'm sure you guys can do it well, right? Okay, because there's really no simple way of multiplying, there's really no shortcut here. I wish there were, but no. So I get a square pi 0, then 2 times this is negative 4 sine square theta, then I'll get plus 4 sine theta sine 2 theta, sub minus minus you get plus 2 sine theta sine 2 theta, and finally you get minus 2 sine square 2 theta. This whole thing integrate with respect to d theta. Okay, so now if you're careful, you do the simplification correctly, blah blah blah, we should arrive at this expression easily. Okay, this one would just be what you see on top. Okay, a square, sorry, they want it in their in the form which they want, right? Pi 0 a square, then this is 4 sine square theta. We need to factorize out the negative. Okay, this is part of showing, because it's a show problem, so it's a bit more involved. So we're going to factorize out the negative sign to get to the form which they require. Close bracket d theta. Okay. Okay, so now we have a negative sign and the integral, which is a bit jarring, right? Because it's the lower limit is a more positive value than the upper limit. So we're going to put the negative in and transform it to from 0 to pi of the same thing, huh? Then bracket shown. Okay, that's how you get the 3 marks. This is worth definitely more than 3 marks in my opinion, but hey, who cares about my opinion? So now, right, so because we realize there is no negative in front here, that's why I know they required us to do the flip over the limits. So we're going to say theta, therefore theta 1 is 0, theta 2 is pi. This is what is required. Okay, after that's done, that really took a while. Now we have a bigger challenge. And in part 4, right, you're asked to find the exact total area enclosed by C, which means right now we are going to include the part at the bottom, right? The part at bottom. So now, because we know the curve is symmetrical about the x-axis, so in part 3 we found this required area. We've proven this integral, right? Now we just need 2 times of it. So the required area, right? I'm going to write this down. Required area is equals to twice the integral that we have proven in part 3, means 0 to pi a square, this entire thing, right? 4 sine square theta minus 6 sine theta sine 2 theta plus 2 sine square 2 theta. You must be thinking, wow, how am I going to solve this? Well, from your O level, right, or from your IP, IP time, right? This integration of Trigo shouldn't be too difficult. Well, I mean, this isn't too difficult, but it requires quite a bit of manipulation. So now I'm going to just take this out, a square, and I need to do some manipulation before I can integrate the Trigo functions. Because sine square, right, there's no way we can integrate sine square directly, right? But we know that cos 2 theta is 1 minus 2 sine square theta. So, sine square theta is actually 1 minus cos 2 theta over 2. So that handles this part, right? 4 sine square theta is 2 minus 2 cosine 2 theta. This should be easy to integrate, but we're not going to do that now. Now we have a bigger challenge. This one. Sine multiplied by sine. So if you haven't done this before, this might be a bit challenging, but we just need to think about factor formula. So if you're not familiar with it, just go flip to any formula list and you would see the factor formula. But for just to make this, just so that I don't make this video as too long, I'm just going to write down the result for you. So if you have negative 6 sine 2 theta, right? Negative 6 sine 2 theta, theta sine 2 theta, right? Is equals to 3 times of negative 2 sine 2 theta sine theta, which is using the factor formula, right? You need to be able to work both sides of the formula. So now I'm working from the right hand side that you see on your formula list, working to the left hand side. So negative 2 sine, apologies, I should follow the same order, negative sine, negative sine 2 theta sine theta, right? You should be able to see it as negative 2 sine 3 theta plus theta over 2, and this is sine 3 theta minus theta over 2. Okay, 3 theta plus theta is 4 theta, 4 theta over 2 is 2 theta. So why do I want to put it in this form? You realize that in the right hand side you get p plus q, right? This p plus q over 2, this p minus q over 2, which means the result is cosine 3 theta subtract cosine theta. Okay, so we have changed this negative 6 sine theta sine 2 theta into something that we can actually integrate. So negative 6, right? It becomes plus 3 cosine 3 theta minus 3 cosine theta. Okay, then this 2 sine square 2 theta, right, shouldn't be a big deal. Because if you know 2 sine square theta is 1 minus cos 2 theta, 2 sine square 2 theta will just be 1 minus cosine 4 theta. Okay? Plus 1 minus cosine 4 theta. So you see how evil this question is? You know, all these cosine thetas, there's nothing for you to combine. So, you know, we have to integrate them each separately, but of course at this stage, it actually becomes quite easy to integrate. So now, of course, I'm doing the integration. I'm going to change this to my square brackets. This is 2 plus 1, 3. Sorry, I forgot my d theta. 2 plus 1 here is 3. 3 integrate and you just get 3 theta. Then the rest should be very easy. Okay, integrate cosine, you get positive sine, right? Sorry, you differentiate cosine, you get negative sine. So you integrate cosine, you get sine, isn't it? So this one minus 3 cosine theta, right, will just be, the sine is still not changed. You don't change the sine, minus 3 sine theta, correct? And then this one, now we have 2 cos 2 theta. The sign is not changed, but now we need to divide by 2, right? Because of the coefficient of theta here. So it's sine 2 theta. And then this 3 theta, same thing, plus sine 3 theta. And then this 4, we should see 1/4 sine 4 theta. So then we are going to sub in our limits now. So it shouldn't be too difficult, right? But of course, how you arrive at this simple integral to integrate, that took a bit of work. Okay, which means you need to know your factor formula quite well. So over here is 3 pi minus 0. So sine pi is just 0. Sine 2 pi is still 0. Sine 3 pi is also 0. So sine 4 pi, integer multiple of pi, is just 0. So okay lah, they're not that evil. And then you realize, right, if you sub in 0 here, 0, sine 0 is still 0. Ta-da! So the exact final answer will be 6 a square pi units squared. Okay, so that wasn't really too hard, but that's assuming you know how to transform the integral into something which you can integrate, and then doing this integral correctly shouldn't be too difficult. It's just tedious. You just need to be calm and get your marks, okay? So I know this is kind of hard, but actually if you look at our working, this 5 marks wasn't that long compared to the rest. So now, okay, we've completed this question. So this got us 12 marks. Not too difficult, not too easy. Just have to think clearly. Okay, I think that's all I have to say for this question. As always, have a kitty nice day. Stay safe and work hard. If you found this video useful, please like and subscribe and tell all your friends. Thank you.